Hi everyone. Today we're going to talk about partial fractions, and that's section 7.3. To go ahead and get started, the steps for decomposing fractions is to decompose into separate fractions, multiply by the LCD, that is going to be our least common denominator. Group by like terms, factor the common variable and not the coefficient. We will talk about that today, but that is an important detail when we go into our notes. And then to set equal to coefficient with like degree on the other side of the equation. Okay, so in essence, we're going to be decomposing fractions. We're going to have one main giant fraction, if you kind of look at example 1 there. All right, we're going to break it down into its parts. So what I want you to understand before we even get started is to look at question 3 in these notes. Okay. We have seen questions like this in the past, maybe not as complex, but we have definitely seen something similar. If I were to look at all these fractions and I wanted to truly add them together like it's telling me to do so, to simplify, I would have to have a least common denominator, meaning I want all of my denominators to be the exact same. So looking at all of these, the only way to have the same denominator is if I took all of the denominators as is. Now, if you were to take a look at these two here, you'll notice that they're the exact same. The only difference is the fact that this one is squared. So just to put this in perspective for you, I'm going to go ahead and rewrite it. It's the exact same example, but when I get to that last fraction, instead of saying x plus 1 squared, I'm going to write it 2 times. So when I'm deciphering, well, what is truly the least common denominator? No matter what, I'm going to want the x plus 2 in my denominator because it exists in that first fraction. I'm also going to want an x plus 1 in the denominator because it existed in that second fraction. And then in order to make it a common denominator between all of these, I'm going to include a second x plus 1 fraction, or denominator, excuse me. So what I'm going to do is I'm going to multiply by x plus 2, x plus 1, and then another x plus 1. I'm trying to get a common denominator between all of these terms. And with that, whatever we do to the top, we're going to also have to do to the bottom. All right. So if we go ahead and clean things up here, if I were to distribute that first fraction by what I have given already, I'm going to have 1 times x plus 1 times another x plus 1. The only thing that would have gotten canceled on that case would be the x plus 2 because it already existed in that denominator. Remember, our new denominator is x plus 2 times x plus 1 times x plus 1. There is no need to cancel anything right now because if we cancel, we're going to be right back to where we started, and that's not what we're looking to do. So then I'm going to go ahead and distribute to the second fraction. This time, I'm going to have the 4 still. The x plus 2 is needed. I already have an x plus 1, but I only have one of them, so I'm still going to have to include another. Same denominator, again, as long as I'm doing it to top and bottom, this is allowed. And last but not least, I'll do this last fraction, and the only thing that last fraction is missing is the x plus 2. And so now I'm just going to clean everything up and distribute all my parentheses. And if you need to pause the video and do it all on your own, that is 100% okay. I'm just going to kind of skip ahead here. So that first fraction is going to produce an x squared plus 2x plus 1. I'll worry about the denominator here in just a second. That second numerator, if I distribute everything, including that 4 out front, I'm going to get a 4x squared plus 12x plus 8. And then that last one, I'm going to get just 2x plus 4. And again, I'm allowed to combine all of these fractions because they all have the exact same denominator. And last but not least, looking up at the numerator, I need to just combine all my like terms. So I'm going to go ahead and highlight the specific like terms with each other. And then I can combine them all. So it's going to give me 7x, oh, sorry, not 7, 5. 5x squared plus 16x plus 13 up in the numerator, and then again the same denominator stays. And I'm going to put a squared on that x plus 1 simply because I know there's 2 of them. Okay, if you want to write them separately, be my guest, that is totally fine as well. So what we just did in example 3, we have seen before. All right, maybe not as complex, but we definitely have combined fractions with common denominators in the past. But what we're doing in 7.3 today is we're going to work backwards. What's happening today is I'm going to give you this fraction, and I'm going to ask you to decompose it into its original form. And there is a way to do it, believe it or not. So those are going back to those first steps, first 5 or so steps on that front page. All right, so just to understand, we have seen the partial fractions when we go to combine them together. We have just never seen how to separate them. So that is new for us today. So we're going to go through the steps here. I'll keep them up here for you as we get started. So step 1, according to example 1, we got x plus 14 up in the numerator and x minus 4 and x plus 2 in the denominator. Step 1 tells us that we want to decompose the fraction. All right, so what that means is we are going to rewrite it, keep it the exact same at first, but then we're going to set it equal. We're going to deconstruct it with new variables that we don't know, which we will call a. And we're going to take that first factor in the numerator, or excuse me, in the denominator. So that's our first partial fraction. I understand that x plus 14 was up in the numerator. We will talk about that here in the future, but not at the moment. And then I had a second factor in the denominator, so I'm going to need a second fraction. And that one's going to be called b up top, followed by x plus 2. So the number of decomposed fractions isn't according to however many terms you have in the numerator. It's actually according to however many factors you have in the denominator. Okay. So once we have decomposed it, we're going to move on to step 2 that says multiply by the least common denominator. Well, the least common denominator in this case is going to be every denominator, as long as I account for it each time. So I have a full fraction on the left-hand side, followed by 2 fractions on the right side. So the least common denominator is going to be just those denominators that I have. So I'm going to multiply by x minus 4 and x plus 2. Now, I understand x minus 4 and x plus 2 occur twice, but they occur on separate fractions. So the least common denominator for all of those fractions, the only thing that's going to be common amongst all of them is going to be a single x minus 4 and a single x plus 2. So now I'm going to go ahead and multiply that in. I have to multiply it into everything. Okay, left side and the right side. Give myself some room here. When I multiply it times that blue fraction on the left, you'll notice that my fractions, my denominator is actually going to cancel nicely. That is 100% why we do this step, so that we don't have fractions any longer. So I'm going to be left with x plus 14. Again, I told you that x plus 14 was going to come in handy later, so you'll see how that plays out as it is still there. Then on that next fraction with a, we're still going to have a out front, But with an x minus 4 in the denominator, it's going to get canceled out, leaving me with just x plus 2. Again, fractions are all canceled out, so this is nice. Moving on with the b. I had x plus 2. Those are going to get canceled, leaving me with x minus 4. All right. Step 4 says to group by like terms. Okay, but before we can do that, we actually have to distribute our variables in with our terms. So the x plus 14 will still stay as is. I'll have an ax plus 2a plus bx minus 4b. Now we can group our like terms. So anything that has x's has to get together. Anything that has just a constant, meaning it has no x with it, if it's an a and a b, that's fine. We can group those together. But we cannot combine them together. There is a difference between group and combine. Group just means you're going to put them side by side. So I'm going to have ax plus bx plus 2a minus 4b. I am not touching the left-hand side at all. In fact, that's going to be the hint that tells me how to continue down the road. All right. So step 5 says factor the common variable, not the coefficient. What that means is if you were to look at this group here, the things that are in common between ax and bx is just x. So I'm going to get to factor that out, leaving me with an a plus b. Now on this second group, you'll notice that it's a 2a and a minus 4b, and what you're used to is you're going to say, well, they both have a 2 in common. But remember the rule, we cannot factor out any coefficients. Those have to stay as is. So I'm going to leave them be. The only thing I was allowed to factor out was any sort of x. It still equals x plus 14. All right, and we're almost there. So now we're on that last step that says set equal to coefficient with like degree on the other side of the equation. So what's happening here is it's saying that this a plus b matches with x, and on this side, what is the number that matches with x? The number in front is a 1. So the way I like to do this is I like to say, well, I'm discussing x here, so I'm going to just validate and make a key to myself that I'm talking about x. And I'm going to note that a plus b is equal to the coefficient of x on that left-hand side, which again I identified as 1. Then I get to do the same thing with my constant. Again, I'm just going to label that this is my constant equation. And my constant says that a positive 2a minus 4b has to equal my constant on the other side, which was just, I lost my 14 there, which is just 14. And now, based off of your homework from the previous night, we have two equations, two systems with the same variables, a's and b's, that are equal to other things. So now we can do the process of elimination. All right, the whole goal is to figure out what was that a at the beginning, what was that b at the beginning, in order to make this work. So if I go and I use elimination, I'm going to eliminate my b's just because I see that one b is positive while the other is negative, so that's already working in my favor. So I'm going to multiply the top equation by a positive 4, giving me positive 4a plus 4b equals 4, and the other equation is just going to come over. No changes to that one at all. And now when I eliminate, my b's go away for now. When I add down, I get a 6a equals 18. And when I finish solving, I know that my a has to equal 3. So a is 100% locked in as 3. And last but not least, I need to still know what my b is. So I'm going to take that 3 for a and plug it back in. I'm going to choose to plug it into this equation. Again, simply because it's the most simple equation set up, you're more than welcome to plug it in for this a here as well. So if I do that, that gives me 3 plus b equals 1. And if I solve for b, I now know that b is negative 2. As soon as I know those coefficients, I get to replace my old fractions. So a is going to get replaced with a 3, still divided by x minus 4. My b gets replaced with a minus 2, and still has x plus 2 in the denominator. And that will be our final answer. You have officially decomposed this fraction to know what it originally was in order to get that x plus 14 divided by x minus 4, x plus 2 at the beginning. Okay, so can you check your work? Can you get a common denominator and work backwards to make sure that you still get that original question? 100% yes. All right. Now, do you want to necessarily? Are you going to want to spend more time doing that? Probably not. But if you need to, you have that option. If you're running across weird numbers, you have that option to move on and to check. So I'm going to go ahead and do question 2. Again, following those same 5 steps from the front of those notes. In order to even get started on this question, however, we have to factor. And we are going to factor not the numerator. We're never going to touch the numerator. The only thing we're going to touch is the denominator. So if I factor this, I'm going to have 9x minus 6 still. And in the denominator, 2 things that multiply to get me negative 24 and add to get me 2 is a positive 6 and a minus 4. All right. So I now know the factored form of that denominator, so I can continue with my steps. I got 9x minus 6 over x plus 6, x minus 4. And that is going to be set equal to 2 fractions, simply because I have 2 factors. So those fractions will be a divided by x plus 6 plus b divided by x minus 4. Taking those fractions and splitting them up. Step 2, multiply by the least common denominator. Well, that's the only denominator, so we're going to multiply by x plus 6 and x minus 4. Making sure to multiply that into every term. From there, I will have 9x minus 6. When I distribute it into the a, I'm going to be left with x minus 4. And into the b, I'll be left with x plus 6. Clean it up a little bit. I got ax minus 4a plus bx plus 6b. Before I can move forward, I need to group my like terms. So the ax and the bx get to go together, while the negative 4a and the plus 6b go together. And then we're going to factor out our x. Just the x. No coefficients, nothing else, just the x. All right. So now I know that a plus b pairs with the x. So I know that this together has to be 9 according to that left side. And then this of my coefficients is going to have to equal a negative 6. So I'll go ahead and move over to the side here and set my functions up. Again, if you need to label them, please do. This is my x, this is my constant. That way you know which one you were talking about. And now we do elimination. So here I'm going to eliminate my a's simply because one's positive, one's negative. That's the only reason why I'm choosing to do one over the other. So that gives me 4a plus 4b equals 36. And a negative 4a plus 6b equals negative 6. My a's will cancel, leaving me with 10b. It's going to equal 30. Divide both sides by 10, and I now know that my b is 3. So that's locked in. In my partial fraction, my b is going to be 3. Going back to my original equations here when I was working with x and my constant, I can plug in a 3 for b. I'm going to choose that x function and solve for a. So I know a is 6. And now to finalize my answer, I'm going to plug in my a and my b both into that partial fraction, being clear that my fraction with the x plus 6 and the x minus 4 match perfectly with the original a and b that I had. All right, so if you happen to flip-flop them and you say x minus 4 first, depending on how you solve them, that's okay as long as it's still the same exact value on the top. So what I mean by that is if I go back to this one here, the x plus 6 version has to have the 6 up top because that goes with a. And then the x minus 4 version has to have the 3 on top as that goes with b. All right, so order doesn't matter as long as the actual fraction matches. So it has to be 3 over x minus 4, and it has to be 6 over x plus 6. All right. Question 3 we did together, and then we have 2 more. So I'm going to go ahead and I think I'll do one of these. Yes. They're both of the same difficulty. I'm actually going to do question 4 here for you guys. 5 you can do on your own, and you have my teacher notes as a reference. And honestly, those are very, very explicit. The steps are written out perfectly. So if you have to or you need to, please look at those teacher notes, as I think they will help a lot in explaining the steps and walking you through each one. All right. So for this one, our denominator is factored. Okay, we have an x in the denominator and an x minus 3 squared. All right, that squared is going to actually play a new role for us. What that means is currently right now in that denominator, if I were to rewrite this fraction and not have that squared any longer, it's going to have x parentheses x minus 3. Oh my goodness, here we go. And that x minus 3 is going to be twice. So looking at this equation, we are going to have x minus 3 written twice, which is going to give us not just 2 factors, but 3 this time. And with 3 factors, that tells me that when I decompose my fraction, I'm going to want 3 separate fractions, simply because that denominator had 3 terms on it. So I'm going to have an a b, and a c. And we'll talk about the new denominators here in just a second. All right, so 3 fractions simply because there were 3 separate factors in the denominator. So the first fraction will keep the first denominator, so the first fraction will just be x. The second fraction will have x minus 3. And if I get to the third fraction, if I put another x minus 3, that doesn't signify that they're 2 separate fractions, because if this said x minus 3, then that allows me to simply combine these as they have the same denominator. And I'm not allowed to do that because I know there has to be 3 fractions. So what I end up doing on this, and you can even look at question 3 as a reference, is the last one has to get squared. By squaring that, I now take care of the squared from the original question, and I no longer have a common denominator with that b fraction, so I know that it is completely separate from that in the get-go. All right, so that is the trick. If you have 3 factors and one of those factors is getting squared, make sure that you extended it out enough to account for one of those factors and then both of those factors. That is the trick if you want to go and try question 5 here in a minute. So I've deconstructed it. Now I'm going to multiply it by the least common denominator, which in this case is x times x minus 3 squared. Distribute that in. The first one is going to just completely cancel that denominator for me. When I get to a, the only thing that will cancel is the x, so I still will have x minus 3 squared. When I get to b, I'll still have an x and a single x minus 3. And when I get to c, I'll only have an x left. All right. Clean things up a little bit. Again, if you want to pause the video and go ahead and distribute this here, be my guest. I'm going to go ahead and do it for you. I'm just going to do the x's to get started with. I'll worry about the a's, b's, and c's here in just a minute. All right. So now I'm going to distribute all those letters in. We got ax squared minus 6ax plus 9a plus bx squared minus 3bx plus cx. Now I can group them by their variables. So ax squared can pair with a positive bx squared. Then I'm going to move on to just the single x's, minus 6ax, minus 3bx, and that c also comes into play. And the only the only constant I'm going to have here is just 9a, and that's actually going to work in our favor here in just a second. All right, so the only constant I have is 9a. Now I'm going to go ahead and factor those variables out. So when it comes to the x squareds, I'm going to have an a plus b. When it comes to just x, I'm going to have negative 6a minus 3b plus c. And when it comes to just my constant, I have a 9a. That one does not get to factor at all. All right. Now I can set up my equations. When it comes to the x squareds, I have a plus b. But on the left-hand side, I don't have an x squared function or a term with x squared, so that's going to actually have to set equal to 0, simply because there is no x squared on that left-hand side. I don't know the I do know the coefficient it has to be, and it's got to be a 0 in order to make sure it's not actually there. Then I'm going to do the x. I got negative 6a minus 3b plus c. And that one has to equal the coefficient of my x term, which is just 1. Last but not least, my constant, which is only 9a. And it has to equal my constant on the other side, which is negative 18. All right, clean things up a little bit. You'll notice that this function here, 9a equals negative 18, is the only function. So I get to just work with that one and solve for a, giving me a equals negative 2. As soon as I know an actual value, it's locked in as is, and I can work backwards. So I'm going to take that negative 2 and plug it into this one. Negative 2 plus b is going to tell me that b has to equal a positive 2 when I go to solve. And then when I look at that last equation, plugging in a negative 2 for a and a 2 for b, when I go to solve for c, that's equal to 1. excuse me, I got 6 plus c equals 1. C is going to come out to give me negative 5. All right. And now that I know all of those values, I can go back to my decomposed fractions and write things out. So my a was negative 2 divided by x, plus my b, which was positive 2, divided by x minus 3, followed by my c, which was negative 5, this time divided by x minus 3 squared. Okay. Now, just some technical things. If you see my answers on my notes or my study guides or anything like that, this negative can also be replaced with that plus sign there. So, or not with the plus sign, but it can replace the plus sign. So I can also write this the exact same way, but when I get to that last term, I can drop that negative down from my 5 and make it say minus. All right, either one is fine. I'll accept either version. But if you happen to see that on my teacher notes, that is what happened. All right. So this is the only difficulty level, the highest difficulty level we will get to. You will only have a maximum of 3 fractions when decomposing. You will never have anything more. All right. So if you want to go ahead and give question 5 a try, again, you have my teacher notes posted on Teams to look through. Give it a shot, see how we do. If you have questions, let us know, and we'll get on to the next section.